Okay, so for our project, we decided to measure the sugar content of liquids using a laser.
So the goal of the project was to determine the amount of sugar in certain liquids and beverages by finding the index of refraction for those solutions.
So our questions being asked was, can you find the amount of sugar in a solution without ever tasting it? Will the index of refraction be different for solutions with varying sugar concentrations? And will it be different for regular Pepsi versus Diet Pepsi?
So this is basically what we did. The goal of the project was to measure the concentration of sugar dissolved in liquids by using a laser and a hollow prism. The angles of deviation that the laser projected when shown through the prism were found using trigonometry. Once the angles of deviation were found, the refractive indexes could be solved for and compared to one another, and the refractive indexes could then be graphed against the amount of sugar in each solution, and the graph could then be used to solve the amount of sugar in an unknown solution.
So at first we just put plain water in the prism, that's a picture of it right there, and then we set up the laser behind it. And the laser would project through onto the board, and then we were able to mark the points on the board for each solution. So we started with water, and that was our reference point for each solution afterwards. And then we made 3 solutions with different concentrations of sugar to see how the laser point on the board would change for each different solution with the different concentrations. Once we put the different liquids in, the point would shift to the right, and we would mark it each time. And then we would measure the length from the reference water point to the point for each solution. And then we would measure the point from the board to where the laser exited the prism. And then we used trigonometry to solve for the angle of deviation. And then once we got the angle of deviation for each solution, we were able to find the index of refraction for each solution.
We're going to be actually doing this over there in that corner there, so be as confused as you want right now.
You can see how the point will shift as we put sugar in the water that's in the prism right now. And then this is just how we prepared the solution. So we did a 10% concentration, a 20% concentration, and a 30% concentration. So we did 100 grams of sugar, 200 grams of sugar, and then 300, and then it was a total of 1,000 for each solution.
We averaged probably about 120 packets of sugar from the calf. We may or may not have stolen.
Yeah.
So next, seeing how the refractive indexes change for solutions with different concentrations of sugar, beverages with unknown amounts of sugar were tested. The refractive indexes for regular Pepsi and Diet Pepsi were found and compared to the other solutions. So you can see that you got 2 images there. The first one on the left is the laser that pointed through an empty prism with no water whatsoever. And then when you put the water in, it shifts solid like half a meter to the right. And then when you add different amounts of sugar into it, you can see it shifting a couple centimeters each time. And for the second picture, you can just see it actually being angled farther away through the cola or Pepsi.
And then this is just the equation that we use. So the theta MD would be the angle of deviation. We just plugged it in each time for each solution, so we were able to get the index of refraction for each solution.
And so these are the results that we found. We found the length of the laser point shift, we found the angles of deviation and the indexes of refraction. They all line up perfectly as you add more sugar to the solution, the angle of deviation and the index of refraction both increase.
So we first just graphed the angle of deviation versus the amount of sugar in each solution, and you can see that it's basically a linear line and it increases. And then we did it for the index of refraction, and then once we plugged this line, we got an equation for it. And we were able to use this equation to solve for the amounts of sugar in the Pepsi and the Diet Pepsi. So we just plugged in the index of refraction that we found for the Pepsi and Diet Pepsi for Y, and then solved for X for each to get the grams of sugar in each.
So what we found that regular Pepsi has about 123.5 grams of sugar, and for Diet Pepsi it says -5, but probably because different sources of error, it's supposed to be 0. That's what they claim, and that's what we found.
Yeah, and so like the negative can just show like there's no sugar in Diet Pepsi. Okay, so this is just like a closer look at the points that each solution made on the board. So as you can see, the Diet Pepsi was really close to water, and that made sense because Diet Pepsi has no sugar and water has no sugar. And then we'll show them the point first. And then the regular Pepsi is between the 10% and the 20%. So we figured that it'd be between 100 and 200 grams of sugar in the regular Pepsi. And then you can see as the concentrations increase, the points shift more to the right. And then Tyler's just going to show you like when you put sugar inside the prism. So that's plain water right now.
If you want to gather around to see this, it's kind of
It's
hard
not
to see.
exciting, but the point will shift as you put the sugar in.
Yeah, it's going to take a minute to mix all the sugar.